Assalamu alaikum and good day, everybody. Now, in this short session, we want to go through one example on how to solve problem in powder mixing. Actually, in the textbook that we are using, there are many examples in the books which I would not go through with you. And at the end of the chapter, there are also many questions on powder mixing. So this is the one that I'm going to show you is more on how to use the Lacey mixing index. Well, example, you can see that the question is saying that now we are having a mixing process which we want to mix 86 kg of excipient. So excipient basically is a filler, and you want to mix this filler to fill out the volume with 14 kg of drug. Yeah? So the mixture is such that you have 14 kg of drug and 86 kg of filler. So you are using a mixer called Nauta mixer. So Nauta mixer basically is a screw going around, and you mix the uh, powder with the container being stationary, and there is something like a ribbon moving around vertically. And this is very important that this drug ABC is well distributed, and we want to assess the quality of this mixture. So to do this, we are taking sample from the mixture every 15 seconds. Yeah? Every 15 seconds, we are taking sample from the mixture to look at the quality, and what we measure in that mixture is the variant. I will show you what I mean by the variant later. So the quality of the mixture is measured by the variant, and this is based on the weight percentage or the weight fraction of drug ABC, yeah, in the sample. And the data that you obtain from the every 15-second interval is such in the table. So you have the time and also the variant. The question is saying that the quality is measured based on the desired component, which is based on the weight fraction, and each sample that we collected, we tested, is based on 50,000 particles. So 50,000 particles here means this is what we mentioned in the lecture as the scale of scrutiny. Yeah? So we mentioned last time that when you have a user, you should know what is the scale of scrutiny for each mixture that the consumer want to use. So in this case, the question asks us to determine what is the best time for us to complete this mixing process. Yeah? And also we were going to plot the graph for the mixing index with time as well as the variant uh, with time. All right. What information we managed to extract from this question is that the scale of scrutiny now is 50,000 particles. Yeah, and P and Q. P basically is the, now we are using binary mixture. P is the fraction of drug that we have to have in the mixture, and Q basically is a fraction of excipient that we have to have in the drug. So we mentioned that by using lazy mixing index, we are almost like running in a marathon. So when we run in a marathon, basically we have the starting point as well as the end point. So in powder mixing, we mentioned that the starting point is basically completely segregated. So when we first dump in the powder into the container, 14 kg of drugs and 86 kg of excipient. So that is a time which is completely segregated. So the starting point, to know the starting point, is P times Q, or what we call P times 1 minus Q, 1 minus P. Yeah? So it's basically 0.14 times 1 minus 0.14. So this is our starting point. Yeah? So this is our starting point, and we know where we want to stop. We mentioned in the lecture before this that we are not hoping to get a perfect mixture. What we are aiming for is basically the random mixture. Yeah? So the random mixture is given by the same mixture fraction but now divided by the scale of scrutiny, which is the number of particles that we are looking into as to consider this mixture as well mixed. Yeah? So we have P times 1 minus P divided by N. So if we plug in the number, so we should get our starting point and our end point. All right. So we can start to calculate our Lacey index. So this is our starting point, and this is our end point, and this is our starting point, and this is the one which we measure in the table given by the question. Yeah? So this is the sample taken from the mixture every 15 seconds, and what we collected, we put it in here, and we should be able to get our mixing index as such. So you can see the mixing index moving from 0.2 to 0.4 and slowly moving up to near to 1, and after that dropping down. Yeah. So we mentioned yesterday that mixing index basically is a number between 0 and 1. Yeah? 0 mean completely segregated, and 1 mean randomly mixed. That is what we hope to get in the mixture. So if we can present this data in the form of a graph, then we should be able to the mixture. So this is the Lacey index, and this is the axis for Lacey index. As you can see, the Lacey index improved from 0 slowly up to about 1, and after that it drops. Yeah? So it doesn't mean that when you spend more time for mixing, it give you a better mixture. So beyond this point, basically the quality of mixture is dropping. Yeah? So beyond this point, basically the quality of the mixture is dropping. So the first question is asking you, what is the best mixing time? The best mixing time from the graph, as you can see, is more or less around 86 seconds. So if you answer around 86, 84, that should be all right. Yeah. So this is the Lacey index, as you can see. Beyond this point, basically you are wasting money, you are wasting energy to mix it again. You are giving more freedom. Basically, there is no more mixing happen. But what happened is actually unmix start to happen, or what we call segregation start to happen. So this is the best point for that, and this is a graph based on this axis. This is the variant according to time. So variant and Lacey index basically is opposite. Okay, I hope through this example you should be able to understand what is the function of Lacey index and how to determine the mixing time required for binary mixture. Okay, bye.